variable instead of declaring separate variable for each value. It means that we having a array in which we store the same type of data type in our array. If we are declaring the array as an int, then we only put the integers in our array. We are not allowed to put the strings and our char variables. So, and there is a limitation in our array. It means that we already declare the limit of the array in when we declare the data type and the name of an array. So we are not we the insertion is limited in the arrays. If we are having a 5 limit of the array, we are not able to put the sixth element in our array. So let's take an example. If we are having a bag and we are only allowed to put fruits only in our inside our bag, so we are not able to put a vegetable. It means that there is a restriction and there is limitation also. So the bag limit is fixed and the data or the type of the vegetable or a fruits is fixed. So that's it about our array. Let's move forward how we declare the array. Move forward. So how we initialize our array? First we declare the data type and then we having a name of an array, and in the square bracket we give it a size of an array. It means that only 5 integer is present in our array, and we all know the integer contain 4 bytes in our memory. So that's it. Now we are put the elements from the array through the for loop, and it goes so 5 times because our array limit will be 5. And how we indexing occurs in our array, so there is a restriction for our indexing that it always start from 0 and goes till n minus 1. Here n is the size of our array. If the size of an array is 5, then the indexing will goes from 0 to 4. So that's it about the general description of our array. Now we go for the implementation, where we learn how we search our element, how we delete our element, how we insert our element in our array. So now we implement our array. Let's take a int main function, and here it having a return 0. First we initialize our array with a int data type, and our array name is arr, and it contains, let's take 5 elements, and this is the declaration of an array is completed. Now we are moving for the insertion. We having a for loop which goes I is equals to 0 and I is smaller than 5, and each time the I will be implemented. It means that the loop will go from the 0 to 4, means that we insert the 5 element in our array. So that's why we are creating a loop, or we take our elements from for the array at index 0. It's me at index I. It means that if we are putting the first element, it goes to the 0th index, and if we are putting the second element, it goes to the first index of an array. So this is the insertion of an array is completed. So that's it. And if we want to traverse, or we want to print the elements of the array, so again we having a for loop which goes 0th index till 4th index, and each time it is increment, and we having an out statement which prints the array ith index. And let's take us. So that's it. Let's not run it. Okay, first we have to insert our 5 elements. Let's take 12, 13, 14, 15, 25, and let's take 20. So this is how we print. It means that the first element are present at our 0th index of an array, and the second element present in our first index of an array. Now there is a linear search as well. We complete the insertion and traversing. So it's time for our linear search. Let's take out statement. We created another function for the linear search, and in our linear search we are passing our array and the number of our elements. Let's initialize it int and is equals to 5. So now it's time for our declaration. We having a int data type, return type of our function linear search, and it contain the int type array, and we having the int type the number of the element present in an array. So it's for finding the element we are passing the key as well. Which element are you going to find in our array? So we take it from the user. Let's take a key value to be searched. So, and we having a cout statement for the clarity. Okay, now let's pass our key as well in our function. So what is happening in the linear search? We goes 0th index to an index and -1 elements. So it's searching linearly. It means one by one we traverse our array element, and if we getting the array element is equals to our key, then return the index of the element. So let's create a loop first, which goes 0th index to n, and its increment every time. And if our array ith index is equals to our key, then we having a return the ith index. If are not find if we are not getting a element in our array, then we having a return -1. It means that after we traversing the whole array, couldn't find our array, we couldn't find our element in our array, then we return -1. Else if we find our array element, then we return return I, the index of our key. Let's run. Again we need to put the inputs. Let's take 12, 13, 14, 25, 2 and 20. Now let's take 2 as a key, which we want to find, and it returns the index number 3. Means that the 12th index is 0, then it's 1, then it's 2, and our 2 number element is a 3. So that's why we're getting the index number as 3. Now there is a binary search as well in our DSA. So let's move for the PPT to understand better. So these are the advantages and disadvantages of our linear search. So first advantage of a linear search is to be it doesn't require the array to be sorted. But in the binary search, the first condition for our binary search algorithm, we need to get the array in the sorted form, but it doesn't require these restrictions in an array. And in the second, we doesn't not require any additional memory. And in the third, it is a well suitable algorithm for the small data sets. It means that if the size of the array is small, we doesn't think twice to put the linear search algorithm for the searching process, because the time complexity is small in our small data sets. And the disadvantages of our linear search is the time complexity, because if the size of an array is large, we have to traverse each and every elements one by one to get the key, or to find the key of our which is present in our array. So it's a high time complexity algorithm. So that's why we move for the binary search, and it is not suitable for the large arrays. So now we understand what is the binary search. So binary search divided our array into two parts. So this 12, 14, 15, 21 and 24 are the elements of an array, and we divide our array through the mid element. The first half is 12 and 14, and our second half is 21 and 24, and the mid element between these array is 15. So in the first case, we want to search for a 15 key. Our key is 15, and first we find that is the mid element is our key. If it is, then return the mid index, and if it not, we have to go for the further indexes. So our if we are didn't put, if the element is greater than 15, then we go for the second half, and if the element our key is smaller than our mid element, then we are go for our first half. So in this case, we find at the in mid element is our key, so we have to stop and doesn't traverse for the first and second half element. Now we have another case in which we want to find our key 14. So in our array we are having a 14 there. So first we divide the array, and we search that if the mid element is our key. If it is not, then find that if the key is smaller than our mid element, we are go for our first half, which start from 0 till mid minus 1. So this condition is true right here. But if the key is greater than our mid element, then we have to go for the second half, where the start point is mid plus 1 and the final point is n. So here the condition is true. First we find that the if the key mid is equals to our key, then return the mid index, but it is not in this case, then this condition is false, and this condition is true because the key is smaller than our mid element, and we search for our key in the first half of our element, and then we find the key in our first half element. So this makes the complexity n by 2 at every step. So recursively we calling the same function again and again to find a key. So now we have to move forward. In the case 3, we are having 21 as a key, and the first step is to divide our array. So next we have to find that if the mid element is our key. If it is not, then we are go for the first half array, and it goes from the s is equals to 0 till the f final is equals to mid minus 1. So there is a condition over here. If the key is smaller than mid, then we are going for our first half, or we traverse our first half. But here 21 is greater than 15, then we are going for the second half, where the start point is mid plus 1 and it goes to the till end. So these conditions are true, and we are traverse our second half of our array. So that's it. Each time, or the each level, the time complexity will be half. N is the size of an array, and if we get that, if we find that the key element is smaller than our mid element, then we are traverse only half array, not the whole array. And if we find that the mid element is smaller than our key element, then we are going to traverse the second half of the array. Means that the time complexity of each step will goes from n minus 2. We are not traversing the whole array. And there is also a case where we find that the mid element is our key. So this is the best case for our binary search. So that's it. Now we have to code that how we are creating our binary search function. So for moving forward, first we learn about the time complexity of a binary search algorithm. We know that the linear search algorithm time complexity is big O of n. So what is the changes occurs in the binary search algorithm complexity? So in the first iteration, the length of the array is n, and in the second iteration, the length of the array becomes the half, and in the third iteration, the length of an array becomes the n by n upon 4. And if we are traversing till or we iterate it till the kth time, then the length of an array will be n upon 2 power k. So we know how we get the time complexity. Let's take n upon 2 power k is equals to 1. Then we are change. So after solving our equation, we get the k is equals to log n. It means the time complexity of our binary search will be big O of log n, which means that the time complexity of the binary search algorithm is much better as compared to the linear search algorithm. Means so now we are going to code for our binary search. We are creating a binary search function in which we are passing the int type array and the size of an array, and at last the key element to be searched. So that's it. Now we code for our function which returns int or the index of an element. It has a parameter int array and the size of our array and our int key which has to be found. So first we initialize our started variable to 0 and final variable till n, and we are creating a while loop which run until and unless as is smaller than equals to our our final element. Now we are take a int mid by adding start and final element index, and we are divided it into. If the mid element is equals to key, then arrayth mid element is equals to key. Just a minute, I just forget. Is equals to our key, then return the mid index of our array. If it is not, then we are traverse. If the array mid element is greater than key, then we change our final index to mid minus 1. Here the s will be 0 and a final element will be mid minus 1. If it is not, then we go for our first half where or we go for the second half where s will be mid plus 1, s will be mid plus 1 here, and our f will be till n. So if the key is smaller than the mid element, we are traverse or finding our element in a left array, else we are finding our element in a second half array. So that's it. If the key is not present in the array, then return minus 1. So that's it. Let's save it and run. We all know we need to put a sorted array for searching. Let's take 12, 13, 14, 15 and 21. It's a 5 element. So now we want to find 13.
Okay, it's fine. The 13 is present in our first index, so it goes for the second first half for certain, because 13 is smaller than 14. If we are putting 15 as a key, then we need to find our element in the second half of an array. But here the key is smaller than our mid element, that's why we go for our first half and it finds our element and return its index.